Hello everyone, today I'm excited to talk about Prince of Mathematics, Carl Friedrich Gauss, one of the greatest mathematicians of all time. He was a genius who made significant contributions in astronomy, physics, and mathematics. Without further ado, let's dive into it. Gauss was born on 30 April 1777 in Brunswick, Germany. He came from a poor and low social status family. His father had some experience in writing and calculating, while Gauss' mother was nearly illiterate. Despite of his background, he still can demonstrate outstanding performance in his early age. In the age of 7, his elementary teacher, Herr Büttner, assigned his students to do the task of finding a sum from 1 to 100, thinking will get some time for rest. A few minutes later, Gauss gave him the answer, 5050. Why you can get the answer so quickly? Teacher asked. If you're trying to arrange the numbers and you pair off 1 with 100, 2 with 99, and 3 with 98, so on and so forth, add up together, you will get 101 for each terms of it. There are total 50 terms of 101, so 101 times with 50, you will get the answer, 5050. Eventually, if you're trying to generalize the Gauss idea, starting from the formula just now, and you assign the terms 1 to A1, 2 to A2, and so on until the AN for any arithmetic series. With the similar idea, you can get the formula of the summation of the arithmetic series from A1 to AN. His brilliant masterpiece mind didn't go unnoticed. He received sponsorship from the Duke of Brunswick, Carl Wilhelm Ferdinand, to pursue his education in University of Göttingen, one of the most prestigious universities in Europe, which his parents surely cannot afford. While studying at the university, Gauss rigorously proved the theorem made by D'Alembert, which states that the number of solutions to a polynomial equation equals its highest exponent. By extended this principle to include complex number solutions, laying the foundation for the fundamental theorem of algebra. During his studies, Gauss also explored Euclid elements, which focus on geometry. Nowadays, we understood it only applied to flat geometry, not to the curved ones. For example, in the book Euclid Element, it talks about this. As you can see from the screen, it's showing the angle of a line is 180 degrees, the total angle. And there is another example. The relationship between inscribed angle and central angle. Gauss became the first to conceive of non-Euclidean geometry, such as spherical geometry and hyperbolic geometry, after he realized the parallel lines on the Earth's surface didn't follow parallel postulates, which, in simple terms, stating that two parallel lines on the same plane will not intersect with each other. As you can imagine, two lines of longitude are parallel to each other at the equator will eventually converge and intersect at the North Pole or South Pole. Remarkably, one of the non-Euclidean geometry, Riemannian geometry, formalized by his student Bernhard Riemann, inspired Einstein's general theory of relativity, a cornerstone of modern physics, explaining the curvature of space-time. Gauss made many significant contributions to number theory as well. There is a fun fact. Gauss used one of his developments, modular arithmetic, to solve his own birthday problem. Here is the explanation of the modular arithmetic. As you can see from the screen, the general formula can be listed as A congruent to B in mod n, or you can write it in the formula of C plus Bn. In the meaning of A is dividend, n is divisor, C is a quotient, and B is a remainder. During that time, his parents only remember he was born on Wednesday 1777, the week after Ascension Day, using the formula with the details of calculation, he was able to calculate his birthday, 30 April 1777. After concluding that he could learn little from the University of Göttingen, Gauss returned to his hometown area and still doing his research work. In his hometown, he once clashed with his father, who wanted him to take up labor work to earn money and didn't understand the meaning of Gauss' mathematical research. Gauss decided to continue his research work, and his determination didn't disappoint his sponsor, the Duke of Brunswick. Gauss published his groundbreaking book, Arithmetical Investigation, in 1801. Gauss became famous in 1801 by predicting the orbit of the lost dwarf planet Ceres, discovered earlier that year by Italian astronomer Giuseppe Piazzi. Piazzi observed only a small portion of Ceres' orbit in just 9 degrees before it disappeared. Gauss, using his mathematical methods, he accurately predicted its position, allowing astronomers to rediscover Ceres in December 1801. Gauss fell in love with Johanna Osthoff, and they married on October 9, 1805. Their first son was named Joseph, a German form of Giuseppe Piazzi, in honor of the astronomer who discovered Ceres. His sponsor, Duke, later died during wartime, and Gauss lost his funding. To support his family, Gauss accepted the position of director of the Göttingen Observatory and taught some students in the university. Although he mentioned he don't like to teach, but some of his doctoral students became influential mathematicians, such as Richard Dedekind and Bernhard Riemann. Gauss also contributed significantly to statistics, developing the Gaussian curve or normal distribution, a tool widely used in probability and data analysis today. Later in life, Gauss focused on the study of electromagnetism. His work was so influential that the unit of magnetic field strength was named Gauss in his honor. One of his famous contributions in this field is Gauss' law for magnetism, which describes the behavior of magnetic fields. Despite his remarkable intellect, Gauss was a strict, sometimes difficult father. He forbade his son, Eugene, from studying mathematics, believing he lacked the aptitude and insisting he study law instead. Gauss achieved so many remarkable discoveries because of his hard work and dedication to understand the universe. As Isaac Newton once said, "If I have seen further than others, it's by standing upon the shoulders of giants." Gauss' legacy stands tall as one of the greatest of these giants, continuing to inspire scientists and mathematicians around the world. Thank you for your attention. I hope you have enjoyed learning about Carl Friedrich Gauss, the Prince of Mathematics.